So there are 3 points, A, B, and C. One of the values in C is not known. So we have to find the value of that unknown A, given that distance of AB is the same as distance of BC. And then number 2, the abscissa of a point A is equal to its coordinate. Find the distance, and the distance from B is 10 units. What are the coordinates of A? And then next is to find the equation of a plane passing through 3 points. Lastly, find the direction, cosines, and normal to the plane 12x plus 3y minus 4z equals to 65. So let's solve this set of problems. So there are 3 points. A, 1 minus 1, 1. B, we have 1, 3. C, we have 3A. And then I've been told that distance AB is the same as distance BC. So distance AB will mean 1 minus 1 squared plus 3 minus 1 squared equals to square root of 3 minus 1 squared plus A minus 3 squared. That's by definition from the information given. So square root of 2 squared plus 2 squared equals square root of 2 squared plus A squared minus 6A plus 9. So when you square both sides, so you have 2 squared plus 2 squared equals to 2 squared plus A squared minus 6A plus 9. That's obtained by squaring both sides of the equation. So this will be 4 plus 4 equals to 4 plus A squared minus 6A plus 9. So 4 and 4 cancels out. So 4 equals to A squared minus 6A plus 9, which means A squared minus 6A plus 9 minus 4 equals to 0. A squared minus 6A plus 5 equals to 0. Product is 5. Sum is minus 6. Numbers minus 1 minus 5. So I have A squared minus A minus 5A plus 5 equals to 0. This will mean I have A into A minus 1 minus 5 into A minus 1 equals to 0. So A minus 1, A minus 5 equals to 0. So A equals to 1 or A equals to 5. So these are the two values for A. Then the next question is the abscissa of a point A is equal to its coordinate. Remember, abscissa means X value in the coordinate, and coordinate means Y value in a point. So given that the distance from B is 10 units, find the coordinates of A. So if we have this as our point A, AB, and we have a point B. So abscissa and ordinate of A are equal. So if abscissa is A, ordinate is A. And point B is 1 to 3, 1,3. Distance AB is given by 10 units. So what are the coordinates of A? So distance of AB is the same as 1 minus A squared plus 3 minus A squared. So this would give us 10. This by definition in the question. So squaring both sides, we get 1 minus A squared plus 3 minus A squared equals to 100. So 1 minus 2A plus A squared plus 9 minus 6A plus A squared equals to 100. So A squared plus A squared is 2A squared minus 2A minus 6A is minus 8A. 1 plus 9 is 10 equals to 100. So we have 2A squared minus 8A plus 10 minus 100 equals to 0. So we have 2A squared minus 8A minus 90 equals to 0. So we have A squared minus 4A minus 45 equals to 0 by dividing through by 2. So product minus 45, sum minus 4. So we have numbers minus 9 and 5. So we have A squared minus 9A plus 5A minus 45 equals to 0. Then pair A into A minus 9 plus 5 into A minus 9 equals to 0. So we'll have A plus 5, A minus 9 equals to 0, from which A equals to minus 5 or A equals to 9. Then you don't stop there. You now give the coordinates of A. So therefore, the coordinates of A are A is minus 5, comma minus 5, or A is 9, comma 9. So find the equation of the plane passing through 3 points, 3, 6, minus 2, minus 1, minus 2, 6, 6, minus 4, 2, that are non-collinear. Non-collinear means they are not on a straight line. So given 3 points, say P1, X1, Y1, Z1, P2, X2, Y2, Z2, and P3, X3, Y3, Z3, which are non-collinear, then equation of a plane is simply given by the determinant of X minus X1, X2 minus X1, X3 minus X1, Y minus Y1, Y2 minus Y1, Y3 minus Y1, Z minus Z1, Z2 minus Z1, Z3 minus Z1 equals to 0. So in our case, we have three. We have the points 3, 6, minus 2. We have -1, -2, 6. And then we have 6, -4, 2. So this will be x1, y1, z1, x2, y2, z2, x3, y3, z3. So replacing into the formula, we have determinant of x minus 3, -1 minus 3, 6 minus 3, y minus 6, minus then -2 minus 6, -4 minus 6, and then z plus 2, 6 plus 2, because minus 2 is plus, and then 2 plus 2. This determinant should be 0. So that will lead us to determinant of x minus 3, y minus 6, z plus 2, -4, -8, 8, 3, -10, and then 4. Then remember, when you're finding these are 3 by 3 determinant, by cofactor expansion, this position is having a positive sign, and then this position usually has a negative sign. This position has a positive sign. So expanding along the first row, I'll have x minus 3. It has a positive sign. You multiply by the sub-matrix obtained by deleting this column of the element x minus 3 and its row. So we remain with -8, -10, 8, 4. This one has a minus sign, so I'll have -y minus 6. Subdeterminant of the matrix formed by delete the row where y minus 6 is, delete the column where that element is also is. So we'll have -4, 3, 8, 4. Sign of this is plus. Z plus 2. Delete the row and column where the element lies, so remain with the matrix -4, 3, -8, -10. So we get x minus 3. Then the determinant here would be 48 minus y minus 6. Determinant here would be -40 plus z plus 2. Determinant here would be 64 equals to 0. So when you expand, you'll be, in fact, when you can divide through by 8, so that you'll have 6 into x minus 3 minus, so minus would give us plus, and then 5 into y minus 6 plus 8 into z plus 2 equals to 0. And then 6x minus 18 plus 5y minus 30 plus 8z plus 16 equals to 0. So 6x plus 5y plus 8z minus 32 equals to 0. So that is the equation of the plane passing through the given points. And then the last question, find the direction cosines on normal of the normal to the plane 12x plus 3y minus 4z equals to 65. So we have 12x plus 3y minus 4z equals to 65. So remember, the normal here will be given by the vector 12i plus 3j minus 4k. So let me call this one vector D. So the unit vector from this D will be given by D divided by its magnitude. Which will be 12i plus 3j minus 4k divided by the square root of 144 plus 9 plus 16, which is 12i plus 3j minus 4k divided by the square root of 169. So the unit vector will be 12 over 13i plus 3 over 13j minus 4 over 13k. So the direction cosines of D are 12 over 13, 3 over 13, and minus 4 over 13.